Okay. Sounds good.
Should be recording now.
Okay, well, thank you again. I'm going to go on mute and turn my video off.
Thanks.
Same here. Thanks, guys.
Thank you.
All right, yeah, let's wait a few more minutes for people to come in. So in the meantime, we can get the chat happening. If you all want to let us know where you're from or what you're working on, or if you're interested in participating, we'd love to hear from you. So I think we're going to wait for about 2 more minutes to wait for some people to join, because then it's 11:35 PT on my end. So yeah, just hang tight. But yeah, Phil, great. Well, thanks so much for that you're here. And yeah, I'm actually calling in from Los Angeles. What about you, Tyler?
I'm from the great state of Tennessee.
Tennessee.
Just south of Knoxville. It's beautiful weather. The winter is finally dying. And oddly enough, we're going to be heading out to Florida for some time next week. So that'll be nice now that it's finally starting to warm up.
Right, indeed. Well, did you all watch the presentation of Jed this morning? Great. Yeah, so I think like Jed has already talked a lot about Stellar and explained most of the things. So for today's call, I'll mostly will be explaining like some of the things he said and give an overview of some of the things he said, and then give you all the tools you need to start developing on Stellar, which is very exciting. Luckily, this session, the previous workshop just wrapped up. All right, so we got that good to go. So hello, my name is Anke, and Tyler and I will be hosting this workshop with you today. We're very excited to prep you for this hackathon. So I work on community and events at the Stellar Development Foundation, or SDF for short. SDF is a non-profit organization founded in 2014 to support the development and growth of the open source Stellar network, which is what we'll be talking about today. So let's hop quickly into the agenda. So first, I'll be talking a little bit about like what Stellar is and what you can do with it. And then I'll go over the tools and resources you'll need to start developing on Stellar. Then there'll be a small question round for anyone who has any questions about these tools. And then we'll go into how to build a wallet. And that's what Tyler will be talking about. So, and which afterwards, we'll also have another question round. So, next. So, what is Stellar? Stellar is a decentralized open network that connects the world's financial infrastructure. Stellar has no owner. If anything, it's owned by the public. The software runs across a decentralized open network and handles millions of transactions each day. Like Bitcoin and Ethereum, Stellar relies on the blockchain to keep the network in sync, but the end user experience is more like cash. Stellar is much faster, cheaper, and more energy efficient than typical blockchain-based systems. So for end users, Stellar is a fast, efficient network for trading, saving, and spending digital money. It's not in and of itself a consumer-facing technology. Stellar is used by businesses, and their users, wherever they are in the world, can submit transactions to send and exchange all kinds of assets on the network, which deliver in seconds and for a low cost, as Stellar is free to use. So for builders, it's an open financial infrastructure. Anyone can access it, and there's no permission or application needed. So let me show you a few things you can do with Stellar. Stellar allows anyone to create a redeemable, tradable representation of any assets in a few simple lines of code. Are you seeing my screen? Is my screen moving at all? Just checking.
I'm not sure. It's not on my side.
Oh, great.
There we go.
Oh, wow. All right. Sorry, guys. I must have this is interesting. Okay. I hope I'm just moving a few things around so you can see.
Yeah, no worries.
Okay. Yeah, whereby works different because I had it open and it was changing, but for some reason it didn't work. All right. Glad it's working now. So token issuance is the backbone of the Stellar network. It's how Stellar connects the world's currencies, and it's what Stellar was built for. So you can issue a token that represents anything from corn to gold to even an hour of your time as a tutor, for example. So on Stellar, you can also trade your tokens peer-to-peer. Every token on Stellar is exchangeable with any other token on the network. And the Stellar protocol itself connects buyers and sellers. In short, there is this decentralized exchange, aka the DEX, built into the Stellar ledger system. So that means that the base Stellar protocol not only tracks balances, as Bitcoin and Ethereum do, but also tracks and settles trades between balances in a decentralized, ownerless way. So, perfect. It's all showing up, just making sure. Like any payment system, Stellar allows one user to send currency to another. So user A can send user B dollars, tokens, or lumens, or whatever. But Stellar also allows a user to send one currency and have the recipient receive another. Essentially, you can send and exchange money in a single atomic transaction. So these features allow you to build on a more connected and interoperable world that creates equitable access to the global financial system. Large enterprise companies and companies as small as single dev startups have chosen Stellar to move money and access new markets. And you can too. We have some great, I think, RZRblock Hackathon has some great challenges for you to build your project on, and you can choose Stellar as a technology to, build on. So, but of course, building a project using a technology you don't know yet can feel like a lot. But don't worry, you don't need to start from scratch. We've collected a few very easy steps for you to become an expert in no time, and we'll provide you with all the tools and resources necessary to start developing on Stellar. So that said, let's hop into this guide, which contains all the information you need to start learning and developing on Stellar. So to get you going in this workshop, I'll click on this guide and explain some of the key tools it mentions. So let me quickly put this in the chat. All right. I think that should work. All right, let me now share that too. See if you can see my screen. Should work. Perfect. No, I need to put this bigger. Let's see. Sorry about that. All right, wait for my internet to handle the whereby and to handle this document. All right, perfect. So if you click on this link, you can find all of the tools necessary to start building on Stellar. So to get started, I'd take a look, if I were you, to some of these intros to get a little overview of what we just talked about and also what Jed talked about this morning. And we'll talk a little bit about how we'll go through Stellar Quest and show you how to get hands-on experience with Stellar. But before that, I wanted to dive into the Stellar documentation. So now we're going to talk a little bit about the technology and show you the different tools. And so I'm going to start with the developer documentation, which is the canonical resource for building anything on Stellar. So our documentation is fantastic. And something you'll be using a lot is, for example, the glossary. So the glossary contains all these keywords that if you don't understand one thing, you can easily navigate to the one you don't understand. So first, let's go to where to start. So if we go to where to start, it describes how to get started and mentions all the channels dedicated to developers as well, right here. So when we go to the list of operations, the way you're going to interact with Stellar is through very specific, well-documented operations. And each of these operations is going to perform a different action on the blockchain. So you can create accounts, send payments, manage data. For example, if you want to put some arbitrary data on your account, there's a lot of different things you can do. And we'll take a closer look at these operations as well when I walk you through the Stellar laboratory later on. What will be really useful to you is these tutorials where you can create an account. Let's take a look. Send and receive payments, follow receive payments, and more. These are really helpful tutorials for you to get started. So once you're ready to build, one part of the documents, two parts actually, of the documents that are really useful is issue assets, which shows you how to create Stellar network tokens and how to build apps, which will Tyler explain in detail later in this workshop. So you don't need a node to build on Stellar. You can start developing with your SDK of choice. And I think if we can find that here. And use public instances of Horizon to query the ledger and submit transactions right away. And I can show you that as well. Let me see the Stellar stack, API Horizon. In fact, SDF offers two public instances of Horizon, one for the public network and one for the testnet, which you can read more about in our API docs, which are here. I can quickly show this if it works. Yeah. So here is information for Horizon, publication REST API, and the testnet, which is more information about here. And I will also show you this in the Stellar laboratory later. So the testnet is a small test Stellar network. It's free to use, and it functions just like the main public network. And it's the best place to start developing on Stellar since it doesn't connect to real money, and also the best place for you to build during this hackathon. Okay, so let me see. So when we go back, there's also a Stellar App Boilerplate, which is a collection of basic Stellar functions designed for hackathons. And it's a little less intimidating than the Stellar documentation. Let's take a quick look at that. So if you're unfamiliar with Stellar and need to get some kind of code to get started, this is a nice repository boilerplate to get started building a Stellar application. So, all right. So I will definitely check this out if you want to start developing on Stellar. And so next up, I'm going to explain the Stellar laboratory. So the Stellar laboratory is an interface and provides a set of tools that enables people to try out and learn more about the Stellar network. You can build transactions, sign them, and submit them to the network. It also makes requests to any Horizon endpoints. So let's take a look at that. So on the Stellar Laboratory, you can, for example, create an account. You can explore endpoints of various resources like accounts. You can build transactions, sign them, and submit transactions. Let me see. So let's start with generating a key pair, for example. So any account on Stellar needs to have a minimum balance of lumens to be able to go through transactions. So there's this nice key pair generator, and make sure you're on the test network, where you can fund this account with a friend bot. So now I'm going to get some test network lumens. Perfect. Now the account exists on the network. So for example, if I want to make a payment of some sort, I can put in the source account, I can fetch the next sequence number, and I can do all sorts of operations here that I showed earlier. So send a payment, for example, or change trust lines or manage data. And then later on, you can sign this transaction with the secret key here and submit a transaction, and then you'll get an XDR code here. All right, so that's the Stellar Laboratory. I hope I explained it well. Tyler, if there's anything you'll need to interrupt me to explain a bit better, feel free.
No worries, you're doing fantastic.
Great. Okay, yeah, so you can also, this is another tool that I wanted to show you, which is a block explorer and analytics platform for the Stellar network. So let's take a look at this. All right, if it loads. Yeah, and so basically Stellar Expert allows you to find any data of your of any account or any payment, and shows you ledger insights and all kinds of stuff, and also about assets, shows you all the information. So let's say I wanted to get the information of my newly created account. I could look it up. Let me see. Here. All right. And then, yeah, it shows me that I just, my account was just funded with 10,000 lumens by FriendBot. It shows you all the details. It's just a bit nicer interface other than Horizon, because you can also see this in Horizon. But this is just a bit of a nicer interface, and you'll likely use this a lot. All right, so that's more or less it. I mean, Albedo, I just wanted to point out, is a browser extension that is really good. You should definitely take a look at when you're working on any kind of key management. It allows other Stellar apps to request transaction signing or identity verification without ever exposing your secret key. So definitely look into that. And there's some other great resources as well that you can take a look at. Finally, I just wanted to quickly go to Stellar Quest. I might be logged in, so it's not that great to show you. Let me see. Yeah, so I'm actually already logged in. But Stellar Quest is a great and fun way to start developing on Stellar, and you'll get hands-on experience with the tools that I just showed you, the laboratory, and everything else. So it will show you, for example, here in this challenge, your task is to create and fund a brand new Stellar account and that's what I did. So I funded the account, and then you'll use these documents to complete the challenge. So it's actually a really great way to work through the developer documentation, which can be a bit lengthy sometimes, and to use the Stellar Laboratory in a fun way. There's a lot of challenges, and when the Quest series is live, you can also compete for XLM awards rewards. So that's really fun. I think maybe Tyler might be able to talk a bit more about that as well, but I believe the next round is somewhere in March. But yeah, so keep up on that. Yeah, so if you want to start learning on Stellar, Stellar Quest is your guide. All right. For the rest, just take a look at this guide. It has all the things you need. And if there's any questions you may have, feel free to take a look at the Stellar Global or on Discord and ask your question, or Stack Exchange you can ask. And we also added some tips and tricks from the SDF team, and you can take a look at if you want to have some more help. All right, so that's it for me. So I'm going to trying to stop sharing my screen now, if I can navigate through all the... Oh yeah, so I guess I could go actually back to the hackathon and press next. So are there any questions? No questions? You can ask them in the chat if you want. All right, I will stop sharing my screen, and then I'll give the word to Tyler.
All right. Thank you so much, Anke. I appreciate the walkthrough of our different tools and a brief overview on what Stellar is, kind of from a use case perspective. Just to give you a little background on myself, I am the ecosystem evangelist at the Stellar Development Foundation. I've been here for a little over a year now, but I actually have a pretty long history building Stellar applications. The SDF puts on a couple of different funding programs and competitions, whether they're hackathons or the Stellar Community Fund or the Stellar Build Challenge. I got my start competing in those for probably 3 or 4 years, and then they hired me. So that's what I've been doing, like I said, for about a year now. I spend a lot of time talking with developers and helping folks out understand what Stellar is, as well as just getting onboarded at a more technical level. So I do lots of workshops and hackathons and build the demo apps that we have. I create Stellar Quest and work on the challenges there, and communicating in the different Discord and Keybase groups, just trying to support our developers. What we're going to be talking about today is a Stellar wallet. So we're going to be building a Stellar wallet, getting our hands dirty in the code through a repo that I've set up, and just walking through some different Stellar operations and begin to understand how to interact with the Stellar network. If you're brand new to blockchain recently, it can be a little bit intimidating, first of all, because there's like thousands of different blockchains. So first you have to decide which one you want to actually build on. And then just about the time you're starting to wrap your mind around what in the world of blockchain even is, you have to start implementing something at a code level, whether you're setting up nodes or interacting with an API or figuring out what in the world decentralization means. That can be all a bit intimidating. Stellar is actually one of the more approachable blockchains in that you don't have to set up any sort of node or architecture to begin interacting with the decentralized network. And at the end of the day, when we're talking about decentralization, the focus we're really trying to have is control or security, where there's not single entities that own something that it can fall apart, or the rules can change through a group of very select individuals. When you have decentralization, you're kind of running a copy of something across a lot of different nodes, a lot of different instances, a lot of computers are running the same version of something, and then a group of those is agreeing on any changes that are coming into the network. So if it's basically just a database, and then how do you submit mutations or changes to that database? And figuring out a way to do that in a way where there's no single party or small group of people that have control over whatever that database says. Once you have that, you can build all kinds of things on top of it. Once you've got a good way to actually secure something in a decentralized way, you can build all kinds of things on top of that. A great one is finance, right? That's the cryptocurrency. But there's all kinds of other things that you can build once you have a network that's decentralized, that's agreeing about how to update a database. And there's lots of different ways to do that. Ethereum's going to do it one way, even Bitcoin's going to do it a different way, Stellar does it another way. So how you sort of arrive at a decision of which blockchain should I use is going to depend a bit on your use case and also your comfort level of how deep into the weeds do you want to get. How big is your pocketbook on setting up a massive computer to run consensus on a Bitcoin node or an Ethereum node. With Stellar, our consensus model revolves a lot more around trust than trustlessness. So you have lots of entities, several entities, not thousands and thousands, but several entities which are disassociated from each other, but have mutual benefit from setting up a network across each other to agree on something. Hopefully Jed went over that a little bit. There's lots of good documentation about how the Stellar consensus protocol works. But now that we've got that system set up and nodes are agreeing with each other and updating the database, we can begin to build things on top of that. Anke went through a few of the operations that are available on Stellar, whether they're payments or creating accounts or managing data on an account. There's several things you can do, but they are Turing complete. Ethereum would be a Turing complete programming language blockchain where you can kind of do anything, so long as you write in their programming language. With Stellar, we don't have a Turing complete programming language, we have operations. So there's a very limited number of things that you can do, which allows our blockchain to be very focused, very fast, and very cheap, which is fantastic when you're targeting cross-border payments or trying to create a network where you're tying in financial architecture from other parts of the world into the internet, essentially, where financial architecture from all over the world is tying into a network, kind of going from horse-drawn carriages that we might have now to rocket spaceships that can move around very quickly. That's kind of the difference you might get when somebody connects to the internet, and also they have access to information in the same way Stellar's trying to give access to financial architecture, financial freedom all over the globe, which is a big goal. But we have a network that can accomplish that, and lots of participants in our open network that agree that it's important and achievable. And that's kind of what you get when you start building an open network that has a very specific goal that isn't just build anything, it's build something specific. So all of that to say, before I even get into my first slide, I think it's important because we need to understand sort of the why of what we're building, and before we get into too much of the how of what we're building. Otherwise, it's just going to be a bunch of information. It's not going to help you make a decision on whether or not you should use a particular technology over something else. So I think it's important to understand a bit of what Stellar's goal is in financial access, value transfer over other things that blockchain could serve, but may not necessarily be suitable in a network that's not Turing complete. We're not going to talk too much about Turing completeness, though. We're going to be talking about wallets. So hopefully if you spend any time around cryptocurrency, you've heard this term wallet. Hopefully if you've been around and have money, you have a wallet. It's a term that we use kind of to explain where we store our money, right? You put your dollar bills in your wallet, you put your credit cards in your wallet, you put your driver's license. It's where you store things that kind of need to be secure but easily accessible. We've commandeered this term in cryptocurrency to kind of be the place where we store or manage our keys. The problem is that a lot of times newcomers will associate, and even folks that have been around for a long time in the blockchain space will associate wallets with value store. But that's not true. You don't put your money in a wallet, you put keys in your wallet. Keys ultimately are the security mechanism in cryptocurrency or in cryptography. When you're moving things around, when you're using mathematics to secure stuff, keys and signing keys, public and private, asymmetric cryptography is what secures these things. And a wallet is a term that we use when we're talking about where those things are stored, or really where they're accessed or managed or used. So it's not actually all that helpful to use or think of the term wallet. And I think it's worth mentioning that, because otherwise we can get into a bit of trouble when it comes to security, because you might think that so long as keys are in a wallet that it's secure, and that's absolutely not true. If your keys are publicly accessible, if your keys are not encrypted, if your wallet might be on HTTPS, but who cares if the keys themselves are not being managed well, if the keys themselves are not owned by the user. If you're building an application and you have ownership over all of your users' keys, even if they technically have a wallet account, if you have signing power over their money, if you have signing power, ownership over their keys, access to their keys, you own all of their money, and all of a sudden you're operating as a bank. And so it's very important that you understand when you're storing keys or implementing a wallet or talking about wallets, that you understand what you mean and then how to control access to that. Because there's lots of different wallets. There's lots of different kind of objects or implementations of wallet that we have in the wild. So I'm going to break it down. I'm going to back up. I'm not going to talk too much about wallets, and more going to focus on the keys themselves and the cryptography of how this works. So at the end of the day, pretty much in any blockchain, any cryptographic implementation of this decentralized network that is blockchain, we have keys which sign messages that modify accounts or modify the blockchain. So you've got instructions. You say, I would like to change the state of the ledger, the state of the blockchain, the state of the database in some way. That would be your message, the instructions. That's going to take different forms in different blockchains as far as the encoding or the transit method that you send to a server. But it's going to be a message that includes instructions for some type of change or action that you would like to take and that you would like to submit to the network for that change to occur. But for that to actually be ratified and verified, it has to be signed. So, for instance, if I have your public key, I can go and take your public key and make this whole instruction that says, please take Anke's wallet and send all of the money to me, right? I could make a message that says that thing. But unless I have the signing key for that message, unless I have the permission to say, I sign off on this instructions, when I send it to the network, it's going to say, okay, I see the instructions, but I'm not going to write off on this because you haven't signed it. And this again is why decentralization is so important, because if the account that the node that I send that instruction to has been compromised in some way, maybe it's my node and I'm saying to myself, take all of Anke's money and give it to me, well, then it's going to happen, right? I'm a evil, malicious node, and I want to steal everybody's money. So you can't have just one node. You have to have lots of different nodes that are all going to agree, so that it's not just me who has control over actually executing modifications to the database. It takes lots of nodes. So I have to take this message that isn't signed by Anke and send it to lots of different nodes, and they all have to say, okay, I accept this. None of them will, because they have no incentive to, other than maybe my malicious one. And so that's kind of where the security of the cryptography begins to come in, as well as the mechanics for how that is actually accomplished when the instructions are sent to different nodes for verification. So keys sign messages which modify accounts. So we're talking a bit, keys, sign, messages, accounts. There's some terminology there. Let's break down some of this terminology. I've already done it a little bit. Keys would essentially be that asymmetric key pair cryptography or public-private key. The way you sign something, you give that public key to somebody else, and then they can say, okay, I see the signature, I see the public key, and I can verify from the signature that I have and the public key that I have that you did, in fact, sign this with a public key, so I can be assured that the public key actually signed, that you have the signing power over, you have the secret key to the public key for this message that you've signed. And then you have the signature, which proves the ownership and allows, it kind of unlocks that permission, and it signifies control. So I have control over the accounts that I have the secret key for. And then you have messages, which are the transactions, the operations, the instructions, or the commands, the ways that you want the database to change, or the actions that you want the nodes to take. In Ethereum, it might be the code that you want executed in the virtual machine. And then you have accounts, which would kind of be the state of the database, the information, the data, the state of the ledger, your piece of the block in the chain. So those are the different pieces. You can see wallet is missing here because wallet isn't necessarily a term that's all that useful. It's better to think about keys. And then when you think about storing those keys, you need to understand the security concerns when those are being stored. So to recap a little bit, wallets control keys, keys control accounts, and accounts control the world. So at the end of the day, we're looking at accounts. And if we want accounts to be able to do anything, move money, store stuff, make tokens, pass things around, to be able to have an account, you need a key. You'll use the account, you need a key. But to be able to do much with your key, to sign transactions, to verify messages that are incoming, etc., you're going to need this wallet, this place to interact with your keys. So let's talk a little bit again about wallets. So wallets might do some of these things. They might use the keys to submit transactions. So you might have a wallet that submits transactions where you can actually go through the whole process and get to the state of changing the database by submitting a message that's been signed. They might also show balances for accounts, for assets in your account. So you have XLM, you have this many Bitcoin, you have some USDC. It might show some of those things, as well as show like graphs and charts or other things. It might facilitate the trading of an asset on an exchange. So you think maybe Coinbase or Lobster Wallet, where you're able to actually take an asset and swap it for something else and offer trades. Those are things that wallets might do, but any of those things could be excluded from the functionality of a wallet, and it still be a wallet. So what a wallet is, what a wallet must do, what a wallet must be to really be a wallet, to really give that use of a key, which gives use of the account so that you can control the world, is it must store keys. So this is going to be the place where keys are managed, they're stored. And it also must sign messages. So by messages, transactions in our case, but it's essentially the instructions. How do you want to modify the database? It needs to have access to the keys, storage of the keys, and then also sign messages. So it's going to expose the secret via an export. So and it will produce valid signatures. So you'll be able to take your key and maybe go somewhere else with it. But at the end of the day, it needs to be able to produce valid signatures of messages for the keys. So it's essentially, you've got a message, you've got a pen, and you need to sign the message. This is me, I permit this thing to take place. So that you can go and take that signature with the message anywhere. And so long as those things match, they say, okay, this person actually owns the key that was used to sign this message. Therefore, we will submit it. We will modify whatever the database is. We'll give the money to somebody else or perform whatever action. So that's an important distinction, because I think a lot of times we think that wallets are these might be things, but we really need to think about wallets in the must key place, because that's where our security concerns are going to come from. That's where our liability is going to come from, and also our use case is going to come from. So when you're building from this base, you may implement third-party services to do the transaction submission. You may implement the balance showing and the trading of assets somewhere else, because all of those things don't have security concerns as much, because they're just dealing with transactions that are already signed. So these things might be combined, but at the end of the day, what a wallet must do is store keys and sign messages. Let's talk about some wallets in the wild, and you might be disagreeing with me, but let's walk through some items that are wallets in the wild. A classic leather pocket wallet. This is something that stores your keys, your signatures, your credit cards, your dollars. I don't know if you actually put your keys in your wallet, but you know what I mean. And then allows you to use them. It's not also the ATM machine. You take something out of your wallet and put it into the ATM machine to make something happen, but it's that permission of having the credit card in your hand that is the key. Another thing might be a phone wallet. So you might have credit cards logged into your phone. Your phone acts as the storage mechanic, but it doesn't also perform the actions. You don't use your wallet app to actually process the payment when you're entering it at a point of sale system. The tap NFC reader, it's not also processing, it's just taking the numbers and securely passing it to the point of sale system. A paper wallet. So this would be if you print out your secret keys on a piece of paper and put it in a vault, right? It's a storage mechanism, piece of paper with a secret key written on it, and it will allow you to sign messages by taking that secret key. This actually might be an interesting one now that I think about it. Not actually a great wallet because you can't necessarily sign transactions. You would need some other interface, though the interface might directly connect through, like with the QR code. So in that sense, you could sign messages directly through, but the message signing would happen probably on a device. So maybe I need to update this where a paper wallet is not necessarily a wallet, it's more a paper key. There's nothing wrong with a paper key, it's just not a wallet. Corded hardware wallets. Maybe you guys have heard of Ledgers or Trezors. One of my favorites is actually a software-less wallet, like the Tangem or the YubiKey, which doesn't run software. So the Trezor and the Ledger both run software, and so that has to be kept up to date. And there's still some security concerns with those. There's leaks that have happened on Ledger and Trezor with emails and stuff that hasn't been fantastic. And it's still a bit more involved, still very secure, but I really like the softwareless wallets where literally all it does is store keys and sign messages. That's the only software that's kept on the device, is a very, very, very simple interface or software that takes in a string, signs it, spits it back out. And it's powered by the device that it's plugged into. It doesn't have power sort of on its own. Like the YubiKey, literally all it does is print out a string when it's connected to something. And the Tangem card gets power from the NFC reader, signs a transaction, and sends it back. It's incredibly hard, difficult to hack into anything like that. It's the same sort of technology that's used in actual credit card NFCs. So you don't see Visa picking up the Tangem Trezor route, but they are in the Tangem YubiKey route. So I really like those. They do require, though, access to NFC technology, which is becoming more widespread, particularly in mobile phones. But if you're doing like desktop development, you'd need a separate reader for that, or somehow connect it through your phone to your device. But where like a Ledger or a Trezor work a lot better on the web. And then you finally have apps, which is kind of your highest level: Lobster, Keybase, the Solar Wallet. There's Albedo, Huru Wallet, and Stellar Guard. We've got these different wallets that different ones of them may allow exchanging and trading and show you graphs and charts, show you the balance that your account has. And those would be considered wallets, but they perform additional functionality to just the wallet functionality. So hopefully I've expanded your mind a little bit as to what a wallet is, particularly what a wallet isn't, and why that's important. So a wallet is an interface for managing keys. Therefore, a wallet shouldn't infer money storage, but key storage. Keys sign messages, which modify accounts. A transaction is a kind of message. There we go. Let's get to our code. Actually, I don't. As I'm talking, or as you think of questions, feel free to drop them in the chat. I'll glance over there from time to time. So if folks are listening and have questions or would like to just discuss, feel free to drop stuff there. Otherwise, I'm going to push on through to our coding session. So we are going to jump into this GitHub repo. I'm going to close this presentation. So we're all going to head over to GitHub. This would actually be, if you're following along at home, this would be a good time to actually jump onto your computer and start following along with me. The presentation a bit is over. We're going to start jumping into this code and actually looking at this repo might be helpful. So github.com/stellar/docs-wallet. So this is a repo that actually corresponds with our build a wallet tutorial. So I'm just going to open that real quick while you guys are opening that repo. We go to our developers documentation and we go to build apps overview. This is the same repo that's being used in this build apps tutorial. And there's quite a few different branches in this repo. We're going to be focusing primarily on the pay one. There's a few others that do other things like path payments, key store, federate. Like there's some other weird things that you can do with this, and the tutorial will walk through each of those. Each step in the tutorial has a different branch, and we're going to be focusing on this payment branch. Which I don't think you necessarily need to click on it because we're going to go ahead and clone this. So I'm just going to open up my desktop here. I'm going to check one thing real quick, make sure I edited. Yes, these are all up to date. I'm going to clone that docs wallet. I'm going to change directory right into it. So open that up in my code editor. I use VS Code. We're going to open that here. I'm going to npm install this, and then we're going to start walking through it. Get all of our dependencies, and while that is running, you guys can see this all right. I'm going to increase the size of it. This is a Stencil.js project. Stencil.js is quite similar to React, a little bit lower level, and works really good for explaining simple functionality. I love it for tutorials. If you've never used Stencil, don't worry. It's just JavaScript. There are definitely some weirdness pieces to it, like with any framework, but the majority of what we'll be going through, really all of what we'll be going through today, is very, very simple components. So the first thing actually that I want to do is change my, this is going to run real quick. I'm actually going to change the branch. This is our setup branch, which has literally nothing in it, which is where the tutorial starts and should start, but that's not where we're going to jump into because we're going to have a guided tour. So git fetch and then git checkout pay, git checkout pay. Looks like I've changed some
Hey, Tyler, can you make that a bit bigger? It's a bit difficult to see on
sorry
some.
about that.
Yeah, perfect.
Thank you. So if you got to the issue where we accidentally npm installed on the setup branch, just do a git reset hard to unset the changes that were made, and then we're going to check out the pay branch because that's going to have all the components that we need for looking at our basic wallet. So we're going to be building a wallet that is very basic. It's just going to store keys, sign messages, and in this case, the message that it's going to sign is a payment. So check that out. Let's make sure we install again. We'll let that run. There's some configuration options here. We don't really need to worry about any of those at the moment. What we're going to be dealing with pretty much exclusively is inside the components folder, particularly the wallet TS TypeScript file. So let's start here and make sure that npm installed. All right, still running. So first things first, we have Stencil Core, sorry, and the Stellar SDK. So these are really the only two things that we're going to be messing with too much, there's going to be a Stellar account. So as you recall, when Anke created a Stellar account using FriendBot, that has a public key and a key store file, or a secret key, and then it can be in some state account. But we'll cover some of those in a little bit. Just a simple loading state, which will, as things are happening and pending, yay, asynchronous code, will show little loaders. Then we have a very basic component set up with some styling, sets up a tag that we can use in our HTML. Whether or not we want it to be part of a shadow DOM. If you don't know what that is, doesn't really matter. We could set that to true or false. It basically just isolates the code. So if we write styling for it, it won't bleed into other components. Shadow DOM means a lot more than that, but for our purposes, that's what it means. And then we set up some states in our component, our wallet component, including our count. We have a prompter, which will be a little module that'll pop up and let us enter information, the loading state, any errors that come up, and we also have the API server, which gets set up in one of these actual components, or in these events, which we'll look at in a minute. And then there are two events: the component will load event. So this is essentially saying anything that we want to set up before the component renders, make sure and go ahead and set that up. So any state items, and that's coming from this components will load, the events component will load, and that is this events directory here and this TypeScript file here. So we'll notice that we're setting up our server right here. We're going to be using the Horizon testnet. So if you recall, I said you don't have to set up nodes to run with Stellar. You don't, because we do that for you. If you ever get to a production level application, it's highly advised that you set up your own nodes, both to prevent any sort of rate limiting that you might have using our public endpoint, but also to participate in consensus and strengthen the network. We don't want everybody using our network because then there's no strength in that. But when you're just developing and testing and hacking around, using the Horizon testnet is a fantastic resource. So we're going to set our server to this endpoint. And if you wonder what those endpoints are, we go to the laboratory. The testnet one is right here. The public network is right here. And then if you wanted to run laboratory, if you've set up your own watcher or validator node, you could set a custom Horizon URL and passphrase. But we're not going to be setting those up today, so we're just going to use testnet. So we set up our server. That will then modify or fill in this server property here. And then we loaded some key store stuff that basically takes our key store file and derives a public key for it. So rather than actually storing the secret key in raw format, I'm using a key store, which comes from my storage services, because I don't like to store private keys in raw format. I want to protect them with a PIN code, which is what we're going to do in a minute when we get to our wallet create function method, this create account function. So we'll get to that in a minute, but there's a key store. Just understand we're not storing a secret seed in raw form. So if you see key store, that essentially means the whole Stellar account encrypted with a PIN code. And if you appropriately decrypt it, you can derive the public key and the private key from it. We'll look at that in a little bit, but just understand when you see key store running around, what does that mean? That's basically the store, the database, if you will, the client side data store that we're putting our account, our secret into. So it's that much more secure. All right, so we've loaded up our server. We've got our component will load. There's a render function, which actually generates all of the HTML for our project. So don't have much, but there's a few items here. So we'll render all that out in our render method. And then we load in all of our Stellar methods. So create account, update account, making a payment, copy address. We're going to go through each one of these But each method follows its own functional pattern and is separated nice and dry. And then I've got a miscellaneous method that sets the prompt, which has nothing to do with Stellar, so I put it outside that grouping. Yay, readable code. All right, so this hopefully has finished by now. I'm going to go ahead and npm start that, which should start our dev server and open our local server with this wallet app. So I'm going to fire that off, and it should be pretty small. I'm going to grow that. I have an old address in here, so I'm going to go ahead and sign out of that so we can start from scratch. So we have this first initial state before anything has happened with a single button, create account. So we'll kind of be jumping back and forth between the render and then these individual methods. So you can remember we set an account, which comes from that key store. If there is an account, we're going to render out all of the account information. Otherwise, we're going to load in this, you guessed it, create account button. I'm going to go ahead and make this nice and big. All right, so we've got our button here. If there's any errors, we'll spit those out. If there is an account that has a state, we're going to print that out in JSON format just so that we can see what our account looks like. And then also, if there is an account, we'll have a update account button and a sign out button, along with some, you'll notice a couple of different Stellar loaders. Those are those loading icons, which we'll see in a moment. But nothing Stellar specific, so we won't look into how to code those, but they do exist. So let's look at our first create account, because that's the first thing that's popping up here. So we've got a create account, and we're going to ask our prompter for a key store pin code, and then we're going to ask for it again. And this is a promise that basically is just making sure that we have a pin code and that we've set it twice to ensure that we use the same one. We really know what it is. If they don't match or they're missing, we'll throw an error. Otherwise, we'll clear the error. We'll set a loading state. And then we're going to make our first call to FriendBot after we generate our key pair random, which comes from the Stellar SDK. There's a key pair. We're going to generate a random key pair. And this is a key pair is basically a public-private key pair, where you've got a public key and a private key, the thing that will be used to sign messages. A key pair on its own, this is important, a key pair on its own does not actually exist on the network. So if you go over to Stellar Laboratory and you go here and you click this button and you just generate hundreds of accounts, none of these accounts actually exist on the network. They would need to be funded. They're valid key pair strings, but they're not actually creating anything. Until you get them funded, they're just valid key pairs that could be Stellar accounts, but they're not actually Stellar accounts. If we were to look at one of those in our Endpoint Explorer, we would notice, make sure on testnet, we would notice that the resource is missing. We have 404. That's because the account doesn't exist. So that actually something that tripped me up initially. I was like, oh my goodness, I can just create a ton of these. They're not actually on the network. They're just valid strings. So that's what this does, is it generates a valid key pair, but then we actually need to fund this. You can't do anything without a funded account. On the public network, we don't have FriendBot because we can't give away free lumens to anybody that wants to create an account. But when we're in development mode, we've got this nice little tool called FriendBot where you can send it a public key. So we take our key pair and extract the public key and send that public key to FriendBot, and it will give that account 10,000 lumens. So we can actually see this running here. If we take that key pair here and we run it underneath FriendBot, if we actually inspect our network tab, see if I create a network tab thing. When I click this button, you'll see a request go out to that FriendBot, friendbot.stellar.org, with the public key address. So it's using that same URL. This is a great place to find if you're using like raw fetch endpoints or need to interact without an SDK and just use our raw APIs. You can kind of see those requests going out and the different parameters that are used. So it takes that address, funds it. That is an actual Stellar operation that happens over on the FriendBot service. It takes this account, gives it 10,000 lumen, and creates it with those 10,000 lumen. There's a create account operation. And so now when we go and we inspect an account that we've just funded, we'll notice that it does exist and return back an object of an account on the network. So if we were to go over to stellar.expert, for example, like Anke was showing, we switch to the test network and we paste in that public key, we'll notice that that key does exist, in fact, on the network lumens. So we're going to do that same thing. We're just going to do it in code here. We're going to create that account, and then we're going to store that account in this account state that we've already set up. Take the key, the public key pair, and we're going to take a key store using this SJCL library that I've imported here. And we're going to encrypt it with the PIN code. We're going to encrypt the key pair secret with the PIN code and include some additional data on this key store of just the public key, so that if this account comes in, you're moving an account from some other browser to some other browser, it would be able to tell you, okay, you're trying to import this public key. So that's some handy information to have that we don't necessarily need, because we can derive the public key from the secret key, but it's just some nice public data that we include there. I would like to mention that just using a raw PIN code as an encryption method is really not smart, because typically PIN codes are very short, 1, 2, 3, 4. So brute forcing this would be extremely easy. In production, you'd want to use a PIN code stretcher, which would take this PIN code, add a bunch of entropy to it, and allow it to be a much harder to crack entropy for actually doing the encryption on the secret key. So for now, we're just going to use the PIN code. In production, you'd want to use PIN code, or you'd want to use stretching on that, which I have done in a different library that's actually public, so you can go and see that. I'll mention it towards the end. So we have this account, and then if you remember this key store thing on the local database, if you will, we take the key store and we base64 encode it and put it inside the key store object, which will allow us, when we refresh the page or leave and come back, it'll actually be able to pull this right back up and load it into your browser, which is really handy. Then once the account is created, everything's been set, we update the account so that we can actually see that the account has been created, and we get the JSON string back. If you remember back in our render, if we have an account, then we're going to spit out the account state by JSON stringifying the account state, which is this JSON object here. And there's nothing fancy about this. These are just API endpoints. If we just take that and we paste that into the Chrome browser, you can see that we have JSON being spat out. So an incredibly accessible blockchain. Okie dokie. Let's go back here. Let's go ahead and click this button. We're going to see a nice loading icon. It's going to take a couple of seconds while it generates the account from FriendBot, loads it into our browser. We'll put in our PIN code. I'm going to make sure I have a super secure one. 1, 2, 3, 4. No one's ever going to guess. It's going to do all that magic. And while poof, we've got an account with 10,000 lumens. It's got this public key right here, just to prove to you that the magic is working. We'll go ahead and paste that into our block explorer, and no doubt, there's our 10,000 lumens. We go to our lab. We're on the test network. There you go. Account's been created. So that's all fine and dandy, but just making an account on FriendBot is not great. That's not what we want to do. We also want to maybe be able to pass our secret key outside of this application somewhere else. So at the end of the day, remember, Wallet stores keys and manages them. It allows them to be used, signs messages. So one of the usability things of a key is to export it. So that would be copy secret. So this is our public key. This is the thing that we're fine to share and tell other people, send money to this account. In fact, I'm going to do that really quick. Well, we'll do it in a minute. We want to copy our secret. so that we can export this wallet or export this key into some other wallet if we wanted to. So that functionality is copy secret.ts. So if we look at our HTML again, we can see we've got this copy secret. It's triggering this copy secret button, which is this function right here. And this is going to enter your key store pin code. So this is going to force us to decrypt our pin code or decrypt our key store object and then extract from that the secret key that we stored in it when we created the account. So right now, if we copy the address, nothing comes up because the address is secure. We can look at that really quick. Copy address, all it does is just copy the public key. Wicked simple. If we copy the secret key, that prompt comes up. We have to enter our pin code. Let's enter the wrong one, 1223. Oh, CCM tag doesn't match. We weren't able to decrypt it. Unfortunate. 1234, however, error goes away, and when we paste here, we get the secret key. So SDH, I'm not going to read the whole thing, but that's our secret key. And this is the thing that we could use to export and sign transactions on some other wallet, even in laboratory, perhaps. I will take 1 minute before we move on to payment, which is kind of the whole thing we've been going after. Let's actually look at how we would make a payment in the laboratory. Laboratory is the best place to kind of get a good understanding, a good feel for how operations are happening at the REST API level, so at the actual interaction level, before we've abstracted it into an SDK. So you can really start to experiment with what is a transaction, how do I build it, what's going into this transaction, et cetera, et cetera. So what I'm going to do, we're actually going to use this account that we just funded. So we've got this account that does exist. It's got the public and private key. So I'm going to go and build a transaction. So the first thing we need is the account source. So what account is being affected in this transaction you're about to create? Then we have a fee, or actually we have a sequence number. So all of Stellar accounts operate on sequence numbers, and this prevents replay attacks. So if I build a valid transaction and now I sign it and I send it to you, and it says pay me $100, and I run it 100 times, it should only ever pay $100 one time, not for however many times you submit it. And the way you avoid that replay attack or that double spend is through a sequence number. So as soon as the operation is executed underneath this sequence number, the sequence number will increase. And when I try and send this sequence number again, it will fail, saying you've already used the sequence number for something. The next up is our base fee. So this is to prevent spam from entering the network. We charge a very small base fee. So this is in stroops, which is a very small fraction of a lumen. We'll leave that at 100 for now. You can include a memo, which would be just some really basic instructional information or ID information about where this transaction is coming from. So if you have an application, you might include some application logic in that. A lot of these are optional. Transaction sequence number, base fee are not optional, but you can see the optional ones here. We've got another time bound. So if you only wanted this transaction to be submittable for like 5 minutes or something, you could put that in there. Otherwise, this will just be good for eternity to be able to be submitted. Unless, again, the sequence number somewhere at some other time gets consumed, and then it would no longer be valid. Let's make a payment because that's what we're going to be trying to do. I'm going to go ahead and grab this address because my address here, which you'll remember since we created on FriendBot here as well, also has 10,000 lumens. We're going to say I want to send this address some lumens. We're going to send it, we're going to send it 5,000 lumens. Source account is optional because it's going to infer that from the source account that you include up here. You can have a source account that's different from the accounts down here. So somebody could pay the fee, the base fee for the operations, or you could just have this account be the same, the fee be the same as the operation. So that's what we're going to do in this case. It's worth noting that the base fee is charged per operation. So you can have up to 100 different operations in a single transaction. They will each consume the base fee. So this transaction is going to cost 100 stroops, which just to 1, 2, 3, 4, 5, 6, 7, 100 stroops is that many lumens. So if we have 100, add 2 zeros, and then take 2 away, if we had a max, like the most you could possibly stuff into a transaction, that's as many XLM as it would cost to do 100 different operations. And again, the reason that we can offer this kind of functionality, this kind of service at such a low cost is because we're not Turing complete, because we have very limited number of operations, which allows the validators to be very quick and arrive at consensus very cheaply and quickly, because there's only so many things you can do. We'll put in that 100 again. We only have one operation, so it's only going to cost 100 stroops, base fee. We're going to pay that 5,000. The source account is going to assume from this, so it'll be that one, which is this one. Our destination is what we're paying. This source account is being paid out from that one that we created in our create account. I was proving the point there. So now we've got our XDR, our transaction, which means nothing, because what the heck is an XDR? An XDR is kind of, it's like, JSON is a string. It's in English, so it's a little bit easier to read, but a transaction envelope is kind of the same sort of thing. It's just an encoding mechanism that allows us to pass relatively small strings with complex instructions in a format that you can use. You can send through URLs, or it's very easy to copy and paste. It's not a buffer. It's a very simple instruction encoding mechanism by which we pass around information. So similar to JSON, just not as quite as human readable. If you have the need to read XDR, which you definitely will, you can read about the XDR, external data representation documentation there, but you can also paste in XDRs here. And it's very strongly typed. So you have to know what kind of XDR type you're looking at to be able to say what it should decode as. That's what allows it to be so small and compact. This is a transaction envelope. That's typically what you're going to do. Another one would be like results. So if you get errors, you'll paste that into a transaction result. And this will then decode it and tell you exactly what's going on. We've got a source account, which is taking a fee of 100. There's the sequence number. We've got no time bounds, no memo, and there's a singular operation, which is a payment that's going to this account for 5,000 of the native asset. And we haven't signed it yet. So if we were to take this transaction and say, sweet, I want to take this transaction, again, it's kind of the point I was making before, where I can go and make any kind of instructions I want, but when I try and submit it, it's going to fail because I haven't signed it. So you have to have a valid signature, not just a valid envelope or transaction. So let's go back to our build. Should have everything still in here. Now let's go and sign it. Now what signature do we need? Well, we need the signature of the account that's making the actual payment, which came from here. So there's our secret key. And we're going to sign it. And we would add any signature we would need. So right now, the reason that we only need this one signature is because this operation is for this public key, this source account. This is the account that's making the payment. It's also the account that's paying the fee. If the source account for the fee was different than the source account for the payment, we would need two signatures, one for the source account of the fee payment and one for the source account of the actual XLM payment. But because those are both the same, we can just use one signature. And now we've got our transaction that is signed. So if we go back to our view XDR, we'll notice that we now have a signature attached. The signature is valid. Sweet beans. Let's go and submit our transaction. We can take one more look at it here. Click submit. That's going to go to the network and actually make the change. That's all we needed to do to actually change something on the blockchain. Like a new block just went live. This ledger number here just happened. It included our transaction, which had the operation. So if we actually go to the ledger, single ledger number, and we get that, we've got our ledger operation. Let's go take a look at our ledger effect here, the JSON that was spat out. Let's go ahead and take a look at our operations for this ledger. Actually, let's look at our transactions first. Transactions for ledger. Submit that, and we'll undoubtedly see the transaction here, one of the transactions. So it's got all the records that were submitted in this particular ledger. We can see a hash of 0623. So if we go to when we submitted the transaction, we should see that same hash, and it looks like it'll actually show up in sign. So this one right here, the transaction hash 0623E, was that transaction hash that we saw when we got the transactions for the ledger. And that's because that transaction was submitted in that ledger. Ledgers on Stellar clear every 5 seconds or so. Very, very quick. Let's look at the operations real quick because we actually want to see what that transaction included. Operations for ledger. We'll get a very similar output. This time we'll have records, and it looks like there was a payment of the native XLM asset for 5,000 from this account to this BVLV, which I'm guessing is our account. So we'll notice this balance has not increased yet. It should increase to 15,000. We need to update the account. So that is another operation that we're going to look at right now. We have this update account button. So when we look at our render method here, I'm going to go ahead and close the create account. We'll notice there's an update account method. So we'll take a look at that. And what this is doing is going to the server, that testnet server, again, that we set on the component. It's going to look up the accounts. It's going to look up account ID, our public key. It's going to call it, and then it's going to spit out the account. And it's going to grab the balances. It's going to clean up the output a little bit, remove all the stuff that I don't necessarily want to include in the output so that we have a nice clean JSON file. And then when we click update, it'll actually go and grab that from the blockchain. So let's go ahead and execute that. We'll notice that it updates. The last modified time changed, and now we've got more lumens. Fantastic. If we were to remove these pieces and spit out account, it would spit out all of, let me comment this out. It would spit out all of that JSON file, which would be a little bit bigger. Oops, we're importing more than we need. TypeScript likes to yell at me. Can't read. There must be. Let me try and rewrite this. I'm actually kind of curious if that was from my import statement, or if there's actually something in there that needs to be different. Otherwise, we'll just revert for now. But I'm guessing that was because of the that TypeScript. Interesting. Well, I'm just going to go back to the way it was. No worries. Hopefully that will actually work. Good. I'm not sure where that issue came from. We must be assuming some state of this thing to be a particular way when I spit it out. So I must be modifying something that changes what this is actually looking at. But anyway, let's move on to making a payment. So another thing, just kind of interesting, look at the network tab again. When we update our account, you'll notice that a call is made. Nothing fancy or weird going on. It's just an API call that returns the JSON that we saw when we looked at Lab. So Lab and the SDK are doing the same things. It's just the SDK is a nice little wrapper around it, just like an SDK should be. All right, so our nice last piece here that we need to accomplish before we consider this wallet done, or at least feature complete for the day, is this make a payment method. And so if we go back to our render, we will see that there's a make a payment method, which calls this make payment file. And we get a nice, a little bit longer collection of code here that will actually make a payment. So let's walk through it. First thing we're going to notice is we're going to be using that SJCL again to decrypt our PIN code and actually get our secret keys. So rather than passing secret keys around in raw format, they're only ever executed directly in a function. So there's no place to leak or grab that secret key. It's always going to come straight from a PIN code. Next thing we're going to import is some Stellar SDK helper methods and a couple of variables, like our base fee. And then we just have some other helpers. So first thing we're going to do is open up our prompt and ask, how much do you want to send? And where do you want to send it to? It's going to assume native assets. A nice homework challenge for you would be to create a custom asset, right? So it's not just lumens we can pass around. We can make all our own assets. But then we need to be able to make those payments. And instead of sending lumens, we'll send pizza coin or something. Then it'll ask for our prompt for our PIN code. We'll put in our PIN code, and assuming that there are no errors there, it will carry on to the next few lines of code, set up a loader. And now we jump into some Stellar specific code. So let's walk through this. First, it's going to load up the account. Much like we did when we updated the account, it's going to grab our public key in the server. It's going to look it up. And this is so that we can grab the sequence number. You'll remember when we were in laboratory, we set up the sequence number when we were going to create an operation that was going to pay this account. We're going to need to know that sequence number, because otherwise, if we get it wrong, this transaction, this message will fail. Even if it's validly signed, it'll fail because the sequence is not the next sequence in line. We're going to be setting up a transaction, and the reason that we need the account is because we're doing kind of this piece here, this build transaction. We're doing all this programmatically. So we're going to set our base fee, which is that 100 lumens right now. We're going to set up the network passphrase, which is essentially picking this network. So along with the URL, you also need the network passphrase, which in this case, the SDK is set in this variable. Now we're going to add a singular operation. We've set up our transaction body. Now we need to add operations to it. So this piece right down here. There's lots of different operation types. If we go to our JS Stellar docs, there's a whole bunch of these operations. We can find them here somewhere. I think it might just be operation. Here. We've got a whole bunch of these operations. I say a whole bunch, still not Turing complete. This is what you can do on Stellar. These are the operations. So through mixing and matching these, through doing the atomic swaps, remember a transaction isn't one instruction, it's up to 100. So you can make a payment and request payment and create an account and manage and sell offers and accept trust lines for other assets and do all kinds of things in a single transaction. You obviously won't always do that, but just keep in mind that transactions can include lots and lots of different operations. And there's a lot of really fancy, interesting things you can do when you start to explore the atomic nature of a payment, in the sense that it all fails or it all succeeds. So you can do some very intelligent, smart things with that. But by having these limitations of this is all you can do, you allow Stellar to be very fast and affordable, but also very powerful. All right, so we're going to make a payment, operation.payment. That's this guy right here. We need a destination, an asset, and an amount, and optionally a source. We don't need the source because we're going to assume it, just like we did before, from the public key that we used when we created this initial transaction. So it's going to grab that source from here. We're going to set it to the destination of instructions with the index of 1. So that would be this destination that we're setting in the instructions. And then the asset is going to be of type asset native, so that XLM asset. The amount will be from instructions index 0, which is this amount, or back from our PIN code. So whatever we set that first before the space to be, we split that right there. So the first 0 is the 0 index is going to be amount. The 1 index is going to be the destination. Set the timeout to 0, so this transaction will be valid forever. And then we build the transaction. Finally, just like we recall in the laboratory, if we don't sign it, it won't be valid. So we need to make sure we sign that transaction with our key pair, which we get when we decrypt it from the secret. So key pair from secret loads it up from that SJCL secret that we encrypted with our PIN code. We sign it with our key pair. And then we can finally submit the transaction. So we take the transaction, we submit it to the network. If there's any errors, we will spit those out. Otherwise, it will succeed. Log it, any success message. So this is going to log the output of the transaction that was submitted. And finally, it'll update the account. Whether it fails or succeeds, the loader will stop. It'll spit out an error if it fails. It'll console log the output of the submission if it's successful. And the loader will stop, and then we'll update the account. So, and just so you know, there's a bit of an error catch here that I like. That basically says if we're trying to pay an account that doesn't exist. So this is an interesting one. You can't pay an account that doesn't exist yet. If we don't know that the account exists on Stellar, we can't just send money to it. It needs to be created first. So essentially what we do is we hijack. If the error says that there's no destination, the account doesn't exist, instead of making a payment operation, we'll instead do a create account operation where we take the same payment amount, the same balance amount, and we use that as the starting balance. So if we go back to our documentation here and we look up create account, we have a starting balance and a destination. So very similar to a payment, but instead of paying somebody, you actually are creating their account. You're taking that public key and putting it on the blockchain with this amount of lumens to start it out. So if the error is that the account doesn't exist, it's going to run kind of this whole same thing, but instead of making the operation a payment, it'll make the operation a create account. So kind of neat little catch there, if you didn't notice it. So let's go ahead and make a payment. If we let's just go ahead and pay this guy again, right? So he was so kind to us, sent us tons of money, but we actually only needed 1,000. So we're going to send back 4,000 and pay him back. Okay, it's going to ask for a PIN code. Now, when we hit OK, it's going to make that payment, but you might think this would go to 11,000. It's actually going to go a little bit below that because we have to pay the fee. So don't be alarmed when you see a bunch of 9s here after we submit this transaction, because we're also covering the fee, which is another important note that if you're building an application and you need to handle lots of users paying things around, you may need to sponsor fees for people so that these balances remain as people would expect. It is important to have fee payments so that there isn't spamming on the network, but it can make it a little bit tricky who pays that account and how do we obfuscate it away from normal everyday users. So I'm not doing that in this wallet. You might want to do it in yours. We're going to go ahead and submit that, see what happens. See if we get an error, see if we get success. We get success. See a bunch of 9s, just like we thought we would. But that 4,000 was successfully paid. So if we go back to our account here and we explore it, we'll notice that they're also missing 100 stroops, but that they have received their 4,000 lumens back. So they've made a 100 stroop payment. I've made a 100 stroop payment, but other than that, everything has gone according to plan. I am a little bit curious if sometimes, so Stellar Expert is not run by SDF. There's lots of community-run projects. Stellar Expert being one of the best ones, one of the most used public tools. It's fantastic. Sometimes it can be a little bit slow on the testnet side to update when transactions are being pushed, but with any luck, we've waited long enough, and we'll actually see that 4,000 paid back to us. So we paid 5,000, 4,000 was paid back. We paid from this account to that BVLV account, and then they paid us back the 4,000. So you can start to see how that blockchain explorer works. And you've got the operation numbers, which would have the ledger numbers. If we were to look at dashboard.stellar.org, you can actually see these transactions going through in real time. So here's our test net, and every few seconds, another blockchain or another block in the chain will close. All the changes are ratified. All the transactions and operations in that block have been made, and it carries on to the next one. And the machine just keeps on churning, updating the database. All right, so we've created a very basic wallet. Hopefully that was helpful. Didn't intimidate. It's so easy to begin to integrate with an actual blockchain and build things and interact with the network. You don't have to set up nodes. It's incredibly accessible when you're using these public networks, even just generally using Stellar, because we have those limited operations, those very focused operations. It's a very quick blockchain. You're going to be able to interact and accomplish the things that you need to, the payment, value transfer things that you need to very quickly. We also have, as Anke mentioned, just fantastic documentation, a very vibrant community on Discord and Keybase and Reddit. So be sure and jump into those discussions, start getting involved, participate in the hackathons where we have them. Stellar Quest, I'm gonna jump back to that really quick, because as developers or people that want to actually build on Stellar, it's just going to be so good for getting your feet wet, for starting to get comfortable. And it's super fun. You can win these little badges, which are actually public network, kind of like NFTs, non-fungible tokens. You can collect and store in your account. I use Albedo, so you'll have an Albedo account. You can collect all these sweet badges, but to get them, you have to complete code challenges. But code challenges are something as simple as just creating and funding an account, or making a payment, or using multisig. There's so many things we haven't even touched on that are very useful to understand, but can be intimidating to just like, okay, now I've got to learn everything. Stellar Quest will walk you through bit by bit each little piece of functionality that Stellar has. And by the end of it, you'll have a pretty good grasp on everything that's possible with the Stellar network, and be in a good place with the community to ask the right questions, know where to get involved. Stellar Quest is a really great place to kind of get comfortable at a technical level with what Stellar offers. All right, well, I'm going to go ahead and stop sharing my screen here, and we're going to jump into any questions that folks have. Answer those. Otherwise, this has been a ton of fun.
All right, let me know if you have any questions. Feel free to open your mic or just ask the question yourself.
Any ideas about how large the Stellar dev community is worldwide? I'm not sure. If we look at let me jump over to our Discord. So if you jump into the Stellar Global Discord, Stellar Quest has about 1,000 members right now. That's a pretty new community, so that one's kind of taking off. Stellar Global, let me look at. I remember where you actually find these things. Stellar Global has just over 1,000. They have 1,000. They have about 1,200 members, and both of those Discords are actually kind of new. So those are pretty big communities. Our Keybase, Reddit has a ton. So it kind of depends on what community you're talking about. Like if you're talking about a developer community, you've got the Stellar Quest, which is the 1,000, Stellar Global, which tend to be a little bit more developer focused. And then Reddit's going to be just kind of anyone who's heard of XLM and thinks it's interesting. So that's going to be a lot more, but the quality, I guess, or the type of person that you're going to find there is going to be quite different. So tons of people. You'll almost always get your question answered pretty quick. Also, though, the documentation, it's very self-serve. You don't have to ask permission to start building things. There's nobody that you kind of have to get instructions from. The documentation's great. Lots of tutorials and documentation being written, so very easily to access. Good question.
And there's also a Stack Exchange, right, on Google developers. Yep. Yeah.
There's a Google developers. There is a Stack Exchange. both quite active. The Google group in particular, if you're really getting technical and want to start proposing changes or discuss, we have things that are called CAPS, Core Advancement Proposals, so the way that the Stellar network is actually changed. And then we have Stellar Ecosystem Proposals, SEPs, SEPs, that are discussions around interoperability. So if we're trying to understand, so I'm actually in charge of working on a smart contract layer 2 solution for Stellar. So if we wanted to do arbitrary programming and have it interact with Stellar in a very performant way, but not be a part of Stellar itself, so not a part of Stellar Core, what would that look like? We would need to arrive at agreement because it still needs to be decentralized. So everybody would have to do the same thing. And so that's a public open discussion that has to happen. And those often happen in Google groups or in Keybase or Discord. There'll be working groups that form around those particular problems or ideas. It's a very open, community-driven platform network.
Perfect. Does anyone have any other questions? I don't think so. Well, in the link that I put in here, bit.ly/Stellar Hackathon guide will provide all the resources you'll need to start developing on Stellar. Also has the Stellar Quest, all the links to all the documents. So, and also let us know if you have any questions. Feel free to pop some in Stellar Global. There's always in the Discord, which is also a link in the guide. And yeah, you should be good to go. Also, I think Tyler is recording this hackathon of this webinar. So afterwards, if you want to go back and see kind of what he did, you can. I think Tyler, you might have to do it stay on the browser a bit when everyone leaves, and then save it.
No
I can help you with that. Yeah, so that's that.
All right. Thanks, friends. Hope to see you around the community, building stuff. Appreciate the time. Thank you.
Awesome workshop. Thank you.
Bye.
Bye.